we're moving on to Chapter 8. Chapter 8 is going to be stuff that we have done previously, except for it's going to be taken in another step. Remember when we did a lot of factoring before? We're going to do the same concept this time. So you may want to have Factor Finder up on your laptops if you need it. If you don't need it, then I'm probably just going to keep on going with it. You get what I'm saying? So here we go. Simplifying rational expressions. What is the difference between an equation and an expression? An equation has an equal sign. An expression does not. Y'all understand that, yay or nay? Okay, so with that said, everything that we're going to be doing today are expressions. There are no equal signs in them. Okay? What we're doing is making equivalent statements the entire time. We're simplifying it down to its smallest possible package that you can. That is your goal today. Do y'all understand me? Okay, step 1, get rid of all negative exponents. If there's a negative exponent, you need to get rid of it. Remember, if there's a negative exponent in the top, where does it go to make a positive? In the bottom. If there's a negative exponent in the bottom, where does it go to make a positive? In the top. Excellent. Next thing, you're going to factor the numerator completely. When I say factor the numerator, numerator is which part of a fraction? The top. Now, whenever I said we're taking care of rational expressions, rational means fractional. We all understand what I just said. Rational means fractional, meaning we have a numerator, which is the top, and a denominator, demon denominator at the bottom. Do we all understand that? Okay? When I say to factor the numerator completely, there are two things your brain needs to be thinking. Is there a GCF, a greatest common factor in common between each and every term? If there is, I need to pull it out. And then can what's left be put into two binomials? Okay? So we're going to factor the numerator completely. Next, you're going to factor the denominator completely. Same exact concept. Is there a GCF? And can what's left be factored into two binomials? And then you're going to find the domain restrictions. Domain. Whenever I say domain, what letter should you be thinking? X. Domain is X. Range is Y. So whenever I say domain restrictions, I'm asking you, what can X be that allows it to be true the entire time? That I have no false statements. Do we all understand that? Basically, whenever I say we have a rational expression, that means it's fractional. When you have a fraction, can you ever divide by 0? No, you can never divide by 0. So basically what you're going to be doing is you're going to be taking that denominator and you're going to set it not equal to 0. Because if it is equal to 0, guess what? We can't do a calculation on that problem. Then your goal is to cancel anything out that is in both the numerator and the denominator from left to right. They must be exactly the same or multiples. Do we all understand that? So keep those steps there and keep looking at them. And we're going to talk about the next one here, and negative exponents. And we already talked about this briefly. If I have a negative exponent in the numerator to make it positive, it goes to the bottom. If it's in the bottom to make it positive, go to the top. So nothing new there. Okay? The next thing, restrictions, are values that make the denominator 0, making the expression undefined because you cannot divide by 0. Those are restrictions. So one more time, making sure you all understand. That's when the denominator is 0, making it undefined, and you cannot divide by 0. Do we all understand what I just said? That's what a domain restriction is for a rational expression. Finding restrictions, factor all denominators completely and set each factor form of the denominator not equal to 0 and solve. These are the restricted values on X. Okay? So we're going to hop right into this. And I'm going to do a quick review on how to get rid of negative exponents for the first example. So as soon as you see this, you're going to go ahead and you're going to put this whole entire thing over 1. And we're going to put on missing exponents. So the 4 has a missing exponent. Do you remember this? Is everybody ready to go and writing with me? Okay. Should the 4 to the first stay or go? Stays. Should the x to the negative 3 stay or go? It goes to the bottom and becomes positive x cubed. Does the y to the 5th stay where it's at or go to the bottom? It stays. And does the z to the negative 6 stay or go? It goes to the bottom. This is an example of getting rid of negative exponents, just making sure that you all are on the same page as me. Next one. Same exact concept, except for this time we're going to simplify it, remember? Okay? Putting on the missing exponents. 2 is missing an exponent. 5 is not. The bottom is not missing anything. Okay? Now, should the 2 stay or go? It stays. Should the x minus 4 quantity squared stay or go? It stays. Y to the negative 2 stay or go? It goes to the bottom. Z to the 5th stay or go? It stays. So that is all in green is the numerator. Now, the denominator, 5 to the negative 2, does it stay where it's at in the denominator or go to the top? It goes to the top and becomes 5 squared. How about x minus 4 to the negative 5? It goes up top and becomes x minus 4 cubed, or to the 5th. And what about y to the 3rd? Does it stay or go? It stays. So this is going to be 2 times, what is 5 squared? 25. How many x minus 4s do I have? I have 2 here, and I have 5 there to give me a grand total of how many? Give you a grand total of 7. And this is z to the 5th all over. How many total y's do I have now, bottom? 5 of them. And what is 2 times 25? 50. X minus 4 to the 7, z to the 5th over y to the 5th. Okay, now I just quickly went over that with you to remember how we did exponents. Do we all understand that, yay or nay? Excellent. Okay, now let's actually apply some of the things that we just talked about. Okay, so this is the actual first true example of today's assignment. So we're going to follow the step-by-step procedure in the very first slide on the top left-hand corner of your notes. Okay, so the very first thing it says to do, here's my example of 4x plus 6 divided by 2x plus 3. Okay, I have a line for restrictions. Restrictions are what again? Values that make the denominator equal to 0. Now, before we do all of this, we're going to follow those steps. So step 1, do I have any negative exponents anywhere? No. Step 2, what's it say to do? Factor the numerator completely. Please read your paper as I go through the notes. Okay. So whenever I say to factor the numerator completely, what are the 2 questions you should be asking yourself? Question 1 is, do I have a GCF? Is there a common factor between this term of 4x and this term of 6? Is there something in common? A 2. So what we're going to do is we're going to go fish and we're going to pull out a factor of 2. If I pull a factor of 2 out of 4x, what remains? If I pull out a factor of 2 out of the 6, the 3 remains. Do we all understand that? Yes or no? Okay, now go to the denominator. Step 3 says to factor the denominator completely. Again, you need to be thinking about both of those steps. Do I have a GCF in common between the terms 2x and 3? I do not. Can I factor 2x plus 3 into 2 binomials? I cannot. Why can I not factor them into 2 binomials? Because the degree on the x is degree what? 1. I can't break up x to the first evenly. Okay? So this stays as 2x plus 3. Then what's the next step after factoring the denominator completely? It says to find what? The domain restrictions. Well, how do I go about finding domain restrictions? It says to take the denominator, which is 2x plus 3, and set that not equal to 0. So how do I solve 2x plus 3 not equal to 0? What do I do? Subtract the 3. So 2x is equal to negative 3, not equal to that. Divide by 2. Then x cannot be negative 3 over 2. You know what this means? If this thing was an equation, x could be any value except for what value? So my restriction that I put on this line is that x cannot be negative 3 over 2. Do we all understand that? Okay, so we're done with step number 4. Then step number 5 says to do what? Cancel out anything that is exactly the same in both the numerator and the denominator. From which direction, y'all? That's extremely important. So we are going to go from left to right, and I'm going to say, do I have, looking at this 2 right here, a common factor of 2 anywhere in the denominator? I do not. Okay. What about the expression 2x plus 3? Do I have exactly a 2x plus 3 expression in both the top and the bottom? I do, so those can both go away. So my expression simplifies down to just be the value 2. Do we all understand that, yay or nay? Okay, moving right along, next example, here we go. Same exact concept, we're gonna follow the directions and our steps in that first slide on the top left-hand corner. So step 1, do I have any negative exponents? I do not. Step 2, factor the numerator completely. When I say factor completely, I need to look at x squared plus 7x plus 10 and say, do I have a GCF? I do? I do not have a GCF. There is no number. The smallest number up there is a 1, and 1 goes into everything, so that doesn't impact it. So that means I have to go ahead and put this into 2 binomials. So how do I split up x squared? X and x. And I'm looking for factors of 10. 5 and 2 or 1 and 10. That will give me 7. I have to use 5 and 2. And I need them both to be positive. Okay. So I factored the numerator completely. So now let's go to the denominator. Do I have a GCF? I do not. So I need to factor this into 2 binomials again. How do I split up x squared? X and x. I need to have a negative 10 this time, so what's this about my signs? 1 is positive and 1 is negative. And I need to have factors of 10 that will subtract to give me a negative 3. Negative 5, positive 2. Do we all see that? Yes or no? So I've factored the numerator, I've factored the denominator. So step 3 says to find your domain restrictions. So how do we find domain restrictions? So we're going to take our denominator, x plus 2 cannot be 0, and x minus 5 cannot be 0. Do we all see that, yay or nay? So x cannot be negative 2, and x cannot be positive 5. So my restrictions are going to be x cannot be negative 2 or 5. Because what happens if x is negative 2 or positive 5? What will be 0 where? The denominator will be 0, and we cannot divide by 0. It's undefined. Okay? So now, which direction do I work from? Left to right. So do I have the expression x plus 5 that is exactly the same in the top and the bottom? They must be exactly the same. This is a positive x, that's a positive x, but this is a positive 5, and this is a negative 5. So are they the same? No. So I cannot cancel x plus 5 with x minus 5. Can I cancel out an x plus 2? This expression and this expression are exactly the same. So what I have remaining is this right here. How many of you want to cancel out the x's to give you 1 and to cancel out the 5's to give you negative 1? You can't. I want to make myself very clear. This is your final answer. This x is attached to the 5 by addition. It is your head and your body. It's kind of like saying that you and your sibling, you're siblings, but you're not exactly the same, are you? You're from the same family, but you're unique and different. This x is attached to this 5 by addition, making that a very unique expression. The bottom denominator of x minus 5, those are attached by subtraction, making it a whole different expression. Do we all understand that? Yay or nay? Okay, let's do this all over again. Next one. FYI, these may or may not be some homework problems for tonight. Okay, step 1. Do I have any negative exponents? I do not. So step 2, what's it say to do? Factor the numerator completely, so I'm looking for GCFs. Do I have a GCF? I have a 3 that I need to pull out. So if I pull out a 3, what am I left with on top? Y squared minus 1 all over y squared minus 1. Okay, now I'm not done factoring the numerator, am I? So I have to break the numerator down into 2 binomials. So this is going to give me, how do I break down y squared? Y and y. I need to have a minus 1. So how do I get a minus 1? Can't hear you guys. Plus and minus. 1 and 1. Do we all see that? Yes or no? Okay, now look at the denominator. Can I factor that denominator completely? I need to factor that it's two binomials, right? There's no GCF. So I just need to turn that into y plus 1 and y minus 1. Correct? Okay, so now we're going to take a moment and we're going to go back and do what? Restrictions. And how do we do restrictions again? So we're going to take the y plus 1 cannot be 0 and y minus 1 cannot be 0. So that means y cannot be negative 1 and y cannot be positive. So y is not equal to negative 1 or positive 1. Do we all see those domain restrictions? Okay, from what direction do we go now? Left to right. Is there a 3 anywhere in the denominator, a multiple of it, anywhere that I can cancel out? No. How about a y plus 1? This y plus 1 and the bottom y plus 1 go away. This y minus 1 and this y minus 1 go away to give me what as my leftover answer? 3. Do we all understand that, yes or no? Okay, now I threw this slide in here next because this is extremely confusing for most everybody. And I don't understand it, but it's taking me years of teaching for me to understand where your guys' brains are at. So the very first thing I want your brain to understand is what is 5 divided by 5? 1. So the top is exactly the same as the bottom. Would you agree? Okay, well, what happens now? Well, what's 5 divided by negative 5? Negative 1. So what you're telling me is when the numerator sign is different than the denominator sign, the outcome is the opposite sign of negative 1. We correct? So when the top is a positive value and the bottom's a negative value, or vice versa, negative over positive, but the numbers are the same, then it's going to be a negative outcome. Okay? So what's x divided by x? Okay, one more time. 5 divided by 5 was 1. So what's x divided by x? 1. Jack's with you guys every time. Some of you said it correctly, half of you did not. Okay, well, what is negative x divided by positive x? Negative 1. Do we see that? Yes or no? So be super careful with that. You with me? So when the variable is the same but the signs are opposite, the outcome is negative 1. When the signs are the same and the variable is the same, the outcome is positive 1. Do we all get that? Okay, well, let's come over here. Well, what's x plus 2 divided by x plus 2? Because they're exactly the same. Would you agree? Okay, well, what about this? They're exactly the same except for I have a negative here, don't I? So the outcome is going to be negative 1. And then here's where the wheels fall off of it. No. Look, if I go like this, it gives me negative x. If I go like this, it gives me negative 2. These two items right here are exactly the same. The difference is I distributed it, didn't I? Okay, so if I distributed, the outcome still has to be negative 1, and here's why. Look very carefully. Are we paying attention? Negative x, positive x. Are they opposite? Go to the next term in there. Negative 2, positive 2. Are they opposite? So if the expression, if both terms are the opposite sign, in the top and the bottom, it cancels out to negative 1. Do we all understand that? But they have to be both opposite. Okay? If I have one that's the same and one that's opposite, they can't cancel out. Okay? So what I'm telling you is this x plus 2 over x minus 2, guess what? This is exactly that. I can't cancel it out. It's done just the way it is. Do we all understand that? So the only time you can cancel out is if both terms have opposite signs, and then that'll be the negative 1 case. All right? Here we go. x minus 3 cubed and 3 minus x to the negative 1. What do I do? Step 1. Get rid of the negative exponent. Very good. So I'm going to go ahead and put this over 1. Correct? And what stays and what goes? Does x minus 3 cubed stay or go? It stays. And then the 3 minus x, what happens with that? It goes to the bottom. Do we all understand that? Okay, now here's the next thing that I have found throughout the years, jacked with your guys' heads. How many x minus 3's do I have on top currently? I have 3 of them. I know many of you are going to say, Mrs. Yoder, do I have to write this out 3 times? For this example, I want you to write this down 3 times because I have found it's extremely helpful for my students to do that. Because they can see all 3 of them then. Yes? Okay, well here's the next thing. What cancels out? Do I have anything in both the top and the bottom that are exactly the same? X minus 3 and 3 minus x. They're not exactly the same, but they are ridiculously similar. So what I need to do is look to see if both terms are opposite signs. So this is a positive x and this is a negative x. Is that opposite? Yes. This is a negative 3 and this is a positive 3. Is that opposite? So these cancel out to give you what value? Negative 1. So what you're left with is negative 1 times x minus 3 times x minus 3. So how many x minus 3's do you have there? 2. So this is a negative times x minus 3 squared. Do we all understand that? Yes or no? Now, we solved that before we looked for domain restrictions. So if I look for my domain restrictions, my restrictions are going to come from where? 3 minus x cannot be 0, so that means 3 cannot be x. Do we all understand that? Okay, next one. This one is a little bit more involved because instead of having 1, how many do I have now? 2. And how are the 2 fractions attached? By multiplication. So if the 2 fractions are attached by multiplication, that's okay. We just simply marry them all together as 1. So the very first thing we're going to do is we're going to look at the very first numerator. And we're going to say, do I have any negative exponents there? No. Look at the denominator. Do you have any negative exponents there? No. So we need to factor. So 5c minus 15. What's in common there? 5. Go fish. Pull out a 5. If I pull out a 5, what am I left with? C minus 3 all over C. I cannot do anything else with that, can I? Go to the second fraction. Do I have any negative exponents? I do not. So do I have a GCF in the top? What is it? I have a C. There are 2 C's here and 1 C here. So I can pull out a C to give me C plus 3. Do we all understand that? How about the denominator, C squared minus 9? Is there a GCF there? No, so that means I need to factor that into 2 binomials. So if I factor this into 2 binomials, how do I split up C squared? C and C. And I need to have a negative. So how do I get a negative outcome? 1 is positive and 1 is negative. And I need factors of 9 that will give me 0 whenever I add the factors together. 3 and 3. Okay, so we're going to stop right there. And what am I going to look for at this exact moment? Restrictions. And I'm just going to put them right here because I ran out of space and didn't put one there. Okay, that means C cannot be 0. That's done. C plus 3 cannot be 0. And C minus 3 cannot be 0. Do we all see that? So C cannot be negative 3. And C cannot be positive 3. I took each and every denominator, didn't I? Whether it was in the first fraction or the second fraction, it didn't matter. And now we're going to go ahead and we're going to start canceling out from which direction? Always left to right. Do I have a 5 anywhere in the denominator or a multiple of 5 sitting single on the outside? I do not. Do I have a c minus 3 in either denominator? I do. So this c minus 3 and this c minus 3 clear on the right goes away. Totally legal. Do I have a c sitting single by itself down there in either denominator? I do. So those go away. Do I have a c plus 3 sitting single? I do. So those go away. So what am I left with? And it is done. Do we understand that? Okay, now, how are these two different? They're attached by division. Tell me, when you divide by a fraction, what are you actually doing? Multiplying by the reciprocal of what? The first or second fraction? The second. So you know what we're going to immediately do? We're just going to change this division to multiplication, flipping the second fraction. Do you see what I did there immediately? I took the second fraction and I changed the division to multiplication, flipping the second fraction. Y'all okay? Okay, go through the steps. Do I have any negative exponents anywhere in this problem? I do not. So then I go ahead and I'm going to factor every single numerator and every single denominator. Can I simplify 2 minus x? No, I leave it alone. How about the denominator of the first fraction? Is there a GCF? No. Is there 2 binomials? Yes. So I'm going to split this up into 2 binomials. Splitting up x squared, that gives me x and x. Factors of 1. 1 and 1. And I need them both to be positive. Going to the second fraction now. Can I factor the numerator completely? And what is that going to be? Excellent. X plus 1, x minus 1. And then the denominator, what is that going to factor into? I need a negative 10, but I need to have a positive 3, so the 5 is positive and the 2 is negative. Okay, so what should I stop and do at this moment that I know that every single thing is factored? Restrictions. So I'm going to go ahead and I'm going to do restrictions right now. And where do restrictions come from? So x plus 1 cannot be 0, x plus 1 cannot be 0, x plus 5 cannot be 0, and x minus 2 cannot be 0. Do you see how I don't think? I just write down what each one is. I understand that I've repeated the 1 twice. That's okay. I don't have to keep it repeated in my list. Okay? So I know that x cannot be negative 1. I can cross this one off because it's duplicated. X cannot be negative 5 here, and x cannot be positive 2 here. Do we see the 3 domain restrictions there? Okay, now what do I do from left to right now? Start canceling out. So if we look at the numerator, I have a 2 minus x. Do I have a 2 minus x in the denominator anywhere? I have one that is extremely similar. So this is where my brain should be, sounding off saying, look for negative 1 concepts. So how do I do that? Well, this is a positive 2, this is a negative 2. Is that okay? Yes, this is a minus x and this is a positive x. Is that opposite? So what do those cancel out to give you? I'm sorry? Negative 1. Very good. Do I have an x plus 1 anywhere in the denominator? I do. Do I have an x minus 1? I do not, but I have something that's similar to it. This is a positive x, and this is a positive x. Are those opposites? No. So can I cancel out? You cannot cancel those out. Do we get that? Okay. So with that said, what is remaining up top? Careful. You can't forget the negative 1 times x minus 1 all over. What else is left? X plus 1 times x plus 5. This is what is left. Do not forget the -1 that you canceled out, because if you do, it will be wrong. Do we all understand that? Yay, nays? Okay. The next page that I gave you is the sum of cubes and the difference of cubes formula. This is a formula that you apply just like you would if you were doing the area of a triangle, okay? When you apply this formula, this becomes irreducible. What does irreducible mean? It means I cannot factor it down any further. Do we all understand that? Once you apply the sum of cubes or the difference of cubes formula, the second trinomial is irreducible. Okay? Now, here's the kicker. A cubed and B cubed are perfect cubes. Every time. Okay? So the question you're asking yourself is, what letter or number multiplied by itself 3 times gives you that A value? You with me? So how do I apply this? You ready? So the way we apply this is simply by using the formula. So I have 64x cubed minus 27. Now, just to refresh our memory, 1 times 1 times 1 is 2 times 2 times 2 is 3 times 3 times 3 is 4 times 4 times 4 is 5 times 5 times 5 is. Okay, now that's generally about as far up as you generally have to go. Okay, do we all understand that? And basically what you're doing is saying, okay, how do I get a 64x cubed out of this junk on the right-hand side? What number multiplied by itself 3 times is 64? 4. So what you need to understand is in your head, you're taking the cube root of 64x cubed and you're saying that that's 4x. This is your A value. Because we're applying a formula. Then we're going to take the cube root of 27, and the cube root of 27 is going to be, what is the cube root of 27? And this is your B. Now, how are these two things attached? They're attached by what? Subtraction. So is this the sum of cubes or the difference of cubes formula that you're applying? It's the difference of cubes formula. So that means you are going to be applying this formula right here. A minus B. Come on. A minus B times A squared plus AB plus B squared. Okay? That is the factorization of it. Do we all understand that? We know what A is and we know what B is. So we're simply going to apply the formula. You with me? So this says to take A minus B. What's A? 4x. What's B? 3. Go to the next one. It says to take A and square it. So what is 4x times 4x? 16x squared. Then it says to take A times B. Well, what is 4x times 3? 12x. And then it says to take B squared. What's 3 squared? 9. All over my denominator of 4x minus 3. Okay, now from here, what did I tell you is going to happen with this right here? It's irreducible. You cannot factor that any further. So you are done with that part of the polynomial. But we cannot forget to do domain restrictions, correct? So from here, we're going to go ahead and say, well, what are my domain restrictions? How do I get domain restrictions? Take the 4x minus 3 and it cannot be 0. So how do I solve that? Add the 3 over and then divide by 4. Now, from left to right, is there anything in both the top and the bottom that cancels out? Those cancel out, and your final answer is 16x squared plus 12x plus 9. Okay? Now, I've pretty much gone over everything in the notes, covered everything you need to know for tonight's homework. I'm going to pass out tonight's homework to you. Tomorrow in class, we will go over it, and we will go over the next section or the next worksheet of this. If you look at tonight's homework, problems 1 through 8 are very easy. It's like the first 2 or 3 examples that we did with restrictions. Make sure that you put those on there. Turn it over. The back is where it gets a little bit more complicated, but it's still pretty easy. Okay? Any questions?